Okay, so we start now. The first thing we want to review on the last week test. Try to make sure you guys understand it. And I get 2 questions, I get a wrong answer. So we'll be correct that for you guys. So this is number 1. Okay, which answer will be?
It's B.
That,
5.
that will be B. Okay, any question on it?
Hey, Mr. Pham, can you just go over it real quick?
Okay, now, first thing we talk about the genus. All the time, genus, they must be get genus wanted. For example, 5.1 or 3.3. So for the genus, they can work, either they can be breakdown, or they can just working like normal. Okay, if they working at a breakdown, and now you can see they will be substituted by the battery. Okay, plus this side minus this side, and the voltage will be 5.1 volt. If they break down. And now if they're working normal, then they will be look like diode, normal diode. Okay, and that equivalent positive here, negative here, minus plus 0.7 volt. So when you're working with the genus, you have to know that they will be normal or they can be breakdown.
Okay, and this one here, what I'm having a problem with is, okay, it's got 10 plus and 10 minus. So you're basically when they apply an AC signal. So what happens on this particular circuit?
Okay, when you get the AC right here, positive. Okay, so that means you get a 10 volt on this side, right?
Okay.
Okay, so the first thing you can see, the 3.3 volt, they cannot break down. The thing on the other side will be ground. So they will be working like normal diode. So normal diode.
Which one is working like a normal diode?
Right.
No, which one is working like a normal diode?
3.3 volt. The one 3.3 volt, we're working normal. The thing at one side 10 volt, the other side ground. so they not break down. And if they not break down, then you substitute by positive, negative, and the value will be plus, minus 0.7. Right?
Okay.
In the second genome 5.1, they will be break down. The thing is the other side can vote. So they break down, then they will be look like positive here, negative here, plus, minus 5.1. So you add them up, that will be B, 5.8.
Okay.
Yeah, make sure you must be understand how they work.
And Mr. Pham, one last thing on the on this here, is there a particular shape for the output waveform?
Now they get a DC. That's 5.8 volt.
Mr. Pham,
Yeah.
I have a question. The input, the AC cycle first is positive, am I right? If the first input cycle AC starts with negative, then it's going to be, what will be the output voltage? 3.8 or what?
No, the fourth one, they apply positive input.
Yeah, I understand that one, but the first one, suppose negative input is there, then what will be the output?
That's the question 2, I believe. This question is positive.
Yeah, okay, that's fine then. We can talk in question 2. Thank you.
Okay.
Okay. Number 2.
What the answer for number 2?
C.
I also got C.
Number 2 is C.
And just Mr. Pham, if you, I know you went over number 1, but now number 2, can you do the same thing to show me how you got what you got?
Now they apply negative cycle. They will be minus 10 here. Is correct?
Yeah.
So that means 5.1 volt, they will be on normal. The thing is they get 0 volt right here. Okay, and the other side negative, so they are normal. So you can get positive, negative, minus, plus, 7. Okay, and the 3.3 volt will be breakdown. Okay, then you can get positive here, negative here, and negative, positive, 3.3. So add them up, 4 volt, minus 4 volt. That will be C.
Yeah, Mr. Pham, I have a question in this one.
Yeah,
Total is 4 volt, am I right?
minus 4.
y minus 4, since we are taking negative cycle, is that because of that one, or negative 3.3 plus negative 0.7? Like that, it is negative 4 volt.
Right. You add them up.
Okay.
But was he asking how did you get the negative volt?
You add negative to the negative.
Okay.
Yeah, got it. So it is not related to the input negative cycle. Is that correct?
Okay, make sure you get the right answer and keep it. That's what you need to review when you get the job interview. Otherwise, too many things you don't know which one. Try to review before the interview.
Mr. Pham,
Yeah.
again the same question. If instead of negative 10 volts, in this case it is positive 10 volts, then what would be the answer?
You say what? Right now we get minus 10.
No. Instead of input negative 10,
Uh,
suppose input is positive 10. What will be the answer in this case?
okay, so what the voltage you want? What negative what?
No, the input in the question is negative 10 volts.
Now what
If
input you want to change?
to positive 10.
40?
10, positive 10.
Yeah, the positive 10, Mr. Pham, already to explain to you, it's on the question 1, which was the previous one.
Okay. So my question is, when you apply a positive cycle or negative cycle, it's going to affect the Zener breakdown. Is that correct?
Correct.
Okay. Thank you so much. That was my question. Thank you so much. I appreciate.
Same thing, right? What the answer for that?
I got 6.9. A.
Yes, A, agree.
The right answer will be A. Same way, same thing. Number 4. What the right answer?
I got D, negative
D.
15.7.
Correct. The answer will be D. Just the same way. Number 5.
I got 12 volts. A.
What we are?
A, number A.
Right, number A. If you can confusing or you can to ask question, go ahead, okay? We try to make it clear for everyone. Okay, let's see. Number 6.
C.
I
Number,
got
number C. Is C.
25.5 milliampere.
25.5.
How many ampere?
25.5.
Is it 25.5, right?
Yes, sir.
Yes.
A. Number 7.
I got B 6.2, negative 6.2.
That's C.
C,
Yeah.
mine is wrong.
C.
Now try to
C.
see how they work.
Can you explain, Mr. Pham?
Yeah. For this circuitry, they say V in positive. R1 is open. They open right here.
So we're talking about the positive half cycle with R1 open.
That means we're talking about input will be positive here. Okay?
Right.
And R1 will be open. Basically, now you have to deal with 2 things. First thing, the comparator. And the second thing, Zener. Now, if you open here, that means that will be round. Right?
Right.
They go to R2, they go round, that means round. So the voltage here,
But wouldn't the resistor be in there as part of the ground?
that positive input connect to the round. Round is 0 volt.
Yeah, I know, but I'm saying R2 would still be in there,
It
correct?
doesn't matter.
Okay.
It's round, it's round. So 0 volt here, that means you get 0 volt here. Right?
Right.
This point. So now, when you try to work with the comparator, basically they compare in negative to the positive to see which one is higher. So if negative higher than positive, what happened?
Goes into negative saturation.
Minus V maximum, right? Whatever V maximum. Okay? So now if you get the applied positive, they negative have to be higher than positive. So the V out here, they will be going go to V out. Maximum. Okay? For example, you can get up to 15 volt. For example. Then choose inner. Which one will be breakdown? So you can get into negative, okay, minus 15. Which one working normal? Which one will be
D2 is
breakdown?
normal, D1 is in breakdown.
Okay, so the first thing you get a minus here, minus 15 here. They're telling you you get a 0 volt at this point. So D2 will be normal.
Normal.
D1 will be breakdown.
Breakdown.
Okay. D2 will be normal. That you get positive, negative, and that will be positive, negative here, 0.7. And D1 will be breakdown. That means 6.2 volt. And they will be look like positive, negative. 6.2. Okay. So now, what you think you can get? That means this connected to here. Add them up. This number 7. And right answer will be C. Okay, so positive here again. What I want to make sure you understand, this one will be D1 breakdown. D2 normal. So the answer will be minus 6.9. Same thing. Number 8, quick answer.
I got D, but you gave us the answer, Mr. Pham.
The answer
D.
right. The answer will be D, right?
Yeah, I also got D.
That's what I get a wrong answer. So will be given you the score for this point. If you get 85 now, you can get 90.
So D is a correct answer. Am I right or no?
D is correct answer.
Thank you.
And all the information on number 7 get flip-flopped around for number 8.
Exactly. The one it was on normal, now they break down. Okay, number 9. I get the right answer will be B.
Can you explain how?
How? This is a summing amplifier. For R1, RF, what the gain? AV equal minus RF over R1. Minus 10 over 1. Minus 10. Okay? So you have to calculate the output for input 1. Then calculate the output for input 2. Then add them up. Okay? VL1 equal minus 10. That is the gain. Times 0.2. So minus 2. VL2 minus 10 times 0.5 minus 5. Add them up. That's why minus 7.
Yeah, I got it. I forgot the minus sign.
This is the same question, same thing. You have to get the gain 10 divide 10 gain equal minus 1. AV minus 1. That means you take 10K divide 10K. Then you have to calculate the VL1 equal minus 1 times 3. VL2 equal plus 1 minus 1 times 1. VO3 minus 1 times 8. Okay, let's see, the number 10 will be C. You calculate VO1, VO2, VO3, then add them up. Okay?
Next.
Okay, the zero level detector is one application of which
A.
one?
A.
A comparator. That's easy. Number 12.
D.
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 Also
A.
got
D. This you need to look into the handout for comparator. They're using the heterogeneous. Number 13.
B.
B. Perfect.
Mm.
You understand it on the heterogeneous. They get to upper trigger, and lower upper threshold.
Hey, Mr. Pham, how many triggers are they in comparators? Well, it depends, but for the most part, what is it, like 2 or 3 or more?
Now you get only 2 trigger.
Hmm.
Only 2 trigger point, no more.
Okay.
That will be more detailed if we have to go through that, go to the comparator. Okay. They want to get the V8 in. They given to you that one here. ID already. 5 milliamp. You don't have to calculate the ID. And you understand that will be VD right here. That will be V8 right here. Okay. So the current ID and IS on the time, they must be equal. So you get 5 milliamp times 220 ohm. Okay, this is a question number 14. Answer will be
B.
good.
B.
A. Okay. Just take a 5 milliamp times 220 ohm. However, pay attention on the unit. Milliamp, then you better multiply by kilo ohm. So 220 have to be divided to 1,000 in order to get a right voltage. And now they want to get a VD. That means the voltage here. VD, VDD, ID
C.
times RD. And this is number 15C. If you're doing a right one, they will be C. Any question? Okay, let me know.
Mr. Pham, can you go to number 14, please?
14.
Yes.
What I'm saying here, this is given to you 5 milliamp, right?
Yeah.
Okay, so Vs equal ID times Rs. Okay. Normally IS ID the same. 5 milliamp. Rs will be 220 ohm. You have to change it to kilo ohm. So that's why you can get 1.1.
Okay. Thank you.
You're welcome. Okay. On number 15, answer will be C. I already given to the formula. VD, VDD minus ID times RD.
Next, next.
E is kilo ohm, so you don't have to change.
Yes.
Okay, VDS.
A,
Yeah,
I forgot A.
VD.
Minus VS.
Okay, so this is number 16A. Yeah, if you understand it, it take about less than 3 minutes. That means you have to do it right away without thinking. You still find a way to do it? No way.
Mr. Pham, we have to think, you know.
Hey, Mr. Pham, we're not as fast as you are.
Now, the thing is interview. You should get about 5 minutes to get through it.
Take you just 5 minutes just to read it. Okay, Mr. Pham, next, number 17.
Good.
An amplified 20 dB gain. Output is 10 volt. They want to know what is the input voltage. Number 17 will be B.
I got B. Right.
All right.
I can see.
Only thing is, if you get a question, then I go to the detail. Otherwise, I suppose you already know how to do what to do.
I got C. What do you think I did wrong?
You got Z as in zebra?
Yes.
C.
Sure.
Okay.
I got the decimal point wrong.
Oh,
Use 10 instead of 20.
okay. Now, amplify get the gain 20 dB. Okay. So basically, AV 20 log V out and V in. Okay. That's just a formula. And equal how many? 20, right?
Yes.
So I take the log V out V in equal 20. Equal 1. Now anti-log or remove the log. Then V out V in 10 power of 1. 10. And they given you the output and they want to know the input. So V in equal V out. Okay, That will be 10 volt divide 10.
Oh. Yes.
So whoever want apply to remote company, there have to be no problem. That means you can do it right away. Okay, so that means 17. Okay, 18. 18, the answer will be
I got D.
D, correct.
You said D as in David? Yeah,
D.
5 watts, yeah.
Doing the same thing. However, the formula will be 10 log of P out over P in. Exactly number 17.
Okay.
Only thing is this a power. So that's why 10 log. Voltage will be 20 log. You see, most of the question will be able answer will be less than 5 minutes.
Less than 5 minutes, but you gave us only 3 minutes.
Okay, what is the power level of 1 dBm?
E.
E.
Number 19. B.
I copied that one off of Kumi paper.
That's why we're wrong.
Mr. Smith, you just take a swing shot every time you don't read it.
You're right.
That one.
C.
I got C.
C. Agree.
Perfect. Answer will be C.
I-
I given you the right answer. If you still don't know how to get that, then you have to question.
Can you do the formula on 20, please?
The formula on number 20.
Yes.
Okay, let's see. An amplifier output 25 watt, and they want dB watt. Now, dB watt. What the formula?
N times log.
Log of whatever P. Divide. That's the dB watt. That's the formula. And then you substitute it you can get 10 log, okay, of P mean 25 watt. Divide 1 watt. So that means you take the log of 25, 10, and then multiply by 10. So that's what you get, 13.98. Okay, any question? No more. Okay, let's see.
Hey, Mr. Pham, you said we got another one of these tomorrow?
Yeah, that's what we will go through it. Okay, this is what we'll be asking you tomorrow. I try to give you something for you to review. Okay? That means the test will be given you the resistor with the color, and you tell what the value. And this is the table you will be needed. Make sure if you not download that, you must be downloaded. Okay? They're telling you the first band will be a first digit, second digit, and the multiply and the tolerance. And this is precision. We don't care. I not ask precision. Okay? I given you example. Let's see. Okay, I given you the resistor here. Okay, this is the first band, 1, second band, 2, third band, and 4 band. Okay? Okay, so now I given to you, the first one will be red. Okay, the second one yellow. Okay, the next one will be orange. And the last one will be silver. Okay, first thing you tell me what are equal.
2. R equal 2.
What do you mean, two? Two what?
Well, it's the first number, so it's 2. Red is 2.
You have to tell me completely they equal how many ohm plus minus how many percent tolerant.
24 kilo ohm.
You
So
say
Yeah.
2, 4
Minus
times 10 to the third. That's 2, 4 times 10 to the third. So
2.4 kilo ohms.
no,
24 kilo ohm.
24 kilo and plus or minus 10% silver.
Oh, I see. Yes. Yeah. I agree with that.
10 minus 10.
it is 24K.
24K.
Yes.
And silver means plus or minus 10% tolerance.
Correct.
Is it correct?
Yes.
Correct.
Yes.
When you put down Mr. Pham, where R equal, I thought you wanted to know something else like, well, R could be 2 and yellow is 4, and orange is
Now
3.
you have to do your calculation.
Oh, yeah.
I want to answer. Now, when you get I equal 24K plus 10%, so what is the maximum?
It's 10%, it's 10% times 24,000.
26.
And whatever number you get, then you take and add it to 24K.
So what is
That's the max.
26.4.
24K plus 10% of 24, right?
Exactly, yes.
26.4.
Okay. Your answer will be 26.4, right?
Correct.
Yes.
That is blood tolerant. I not calculated. Then you will be get the minimum. Will be 24K minus the tolerant.
21.6.
21.6K. You get that?
No.
No.
What did you get to 24K?
Yeah. Red is 2, yellow is 4, orange is 3.
Okay, now. Red,
Online calculator.
Orange is 10 power of 3.
red will be 2, right?
Right.
Yellow will be 4, right?
Yeah.
24, right?
Mm-hmm.
Time. Orange 10 to the power of 3.
Oh, yeah.
1,000.
Thank you.
So that's why you get 24K.
Thank you. Yep, now clear.
Yeah, anything try make it clear. Okay, so the maximum value can be accepted, it will be 26.4K. And the minimum value will be 21.6K. Okay, now the question is, if a DMM measure you get 25K. So is it they will be inside the tolerance or they will be out of tolerance?
Still use
Inside.
Inside.
Okay, they will be exactly inside the tolerance. The tolerance from 21.6 up to 26.4, and they measure DMM, you get 25K, they should be okay. However, if they measure only 20K,
No.
Proud.
20K, so that will be 4, right? Out of tolerance. Okay,
Yes.
that is tomorrow.
Class over?
This one. First thing they will be asking what the name of the circuit.
Half wave rectifier.
Halfway rectified, right?
Right.
Yes.
All right. Now they want the secondary voltage, V second.
It's stepped down.
Yeah, but how do we calculate it?
156 divided by 2. I believe it's 78.
Equal 156, right? Time 1 divide 2. Whatever you get.
So basically you're taking half of 156.
Right.
The formula is V out over V in equals N secondary divided by N primary.
Yeah, this is the formula. V secondary will be equal V in time N 2 divide N1. That means time 1 divide 2. You're still confusing. You have to open the handout to see for the halfway rectifier. And now they say, I want to calculate the V out. What do you think? You can get V out.
It's the secondary voltage minus the voltage drop of the diode.
Perfect. So V out will be equal V secondary minus 0.7.
So it's half of 156 minus 0.7, correct?
All right.
Okay.
Try to learn how to do it. The thing is the test cannot be identical.
So that'll make it 77.3.
Yeah, I don't care. They say if input signal frequency 10K, what the output frequency?
10K?
Perfect. Frequency out equal frequency in. Now you do it for me on number 5. They say V in 120 volt IMS, frequency 1K. What they want to know is what is the peak voltage of the secondary. Who can get the answer there?
Is it not 60?
You got to change RMS into peak.
Oh, right. Oh, okay.
That is a trick point. They
Right.
given you the input VRMS, but they asking secondary will be in VP. Okay? So if you take the 120 times 1 divide 2, you get 60. That's 60 VRMS, not VP.
Sorry.
Then you have to converting into VP. That means 60 divide 0.707.
8487. 84.87.
Yeah, I don't know. Number V, the same thing. Only the tricky will be they given you VIMS and they asking for VP. Then you must be converted. And VOut, same thing. Output frequency will be same thing. Okay. They're talking about full wave rectifier. Okay. You need it. You need to open your note on the full wave. Input look like, and this is the output will be look like. Okay. So now you can get the transformer. Okay. And using the what type of this transformer?
Center tap.
What?
Center tap.
Center tap transformer. That means you can see they divide in the center here to upper and lower. Okay. The value will be V second divided by 2 for upper. V second divided by 2 for lower. Only thing, on the upper they get positive, lower they have to be negative. Okay, the opposite. Think of what I'm saying is when you're looking into the circuitry, you're able to recognize what that circuit. Little more. Okay, so now you can see the output. They will be equal V peak of the primary divided by 2 minus 0.7. You will be need that for tomorrow. If you already get that file, then when they asking, you can open it and you can follow that to do your calculation. Okay, so what the frequency related input output?
Double.
Output frequency will be double input frequency. Okay, that's another thing for your guy to read to make sure you can understand exactly how the full wave rectify working. Okay, this is a question here. What is the name of the circuitry? Basically, that will be a full wave rectified. And then calculate the secondary voltage. You get 200 volt, right? Input. And the ratio of the transformer 2 to 1. So you know the output supposed to be secondary voltage. And if they say frequency 5K, output frequency will be a double, will be 10K.
So Mr. Pham, so if this is, if each one of them is 100 volts peak, so peak to peak is 200, the secondary for peak to peak would be 100?
100 must divide a half here, right? A half of the up on the top here.
Oh, yeah, because it's center tap.
Yeah. So you get around here 50, right?
Right.
Get 50. And the V out will be because secondary minus 0.7. Okay, now what's the name?
Bridge.
Bridge rectifier.
Bridge rectifier. That means when you get a positive, then which diode will be on? When you get a positive, diode on will be
D1 and D2.
and D2. Okay? And when you get a negative part of the secondary, then the diode will be on will be D3 and D4. So that's why you get full wave rectified.
1 and 2 works together, and 3 and 4 works together.
Right.
And one is forward bias, and the other is reverse bias.
Yeah, in here, they will be giving you a little more detail, and the output will be a full wave. Okay? Same thing. However, on that one, they given you the formula to calculate the V out. They will be V of the secondary minus 1.4. Think that you get 2 diode, each one will be dropped 0.7. So that's why minus 1.4. Make sure you have to get this thing. Tomorrow you can using the formula to do your calculation. Okay, same thing. They asking the name, that the bridge rectified. They want the big output voltage for bridge rectified, so assume practical model. That means diode will be 0.7. The transformer is specified to have a 12 volt RMS in the secondary. That means in the second year, they already given to you. You don't have to do calculation. They given you 12. And 60 hertz. They want to calculate the big secondary. Only thing is you have to convert in 12 volt RMS into the VP. And then you want the V out, then you're using formula VP minus 1.4. And the frequency, they will be double.
So the frequency is 120?
You mean, I don't know. First thing you convert in 12 volt RMS into feet. Take 12 divide 0.707.
But I'm talking about for the frequency though.
Frequency, they double.
So in other words, the frequency instead of 60 is 120.
Exactly.
Okay.
That's what I said, double. Okay, now let's see. They're talking about here just a power supply filtering. You understand it full way rectified. This is a full way rectified. Okay. You apply sideways coming in, and the output they will be a pulse DC. This is not AC anymore. they will be phone DC. Okay. And now on the second one, output of the full wave rectifier, they go into the filter. Okay. Into the capacitor. So they try to get the output will be only DC voltage. Okay. That means they want the output here supposed to be 5 volts. They supposed to be this way, only DC. However, they still get some in here, right? That means the capacitor charge or discharging. And that's why this one, what the name? What the name
Ripple?
of
Ripple?
Sawtooth?
ripple?
Ripple.
Oh, okay.
Now, what is the ripple?
Is that what they say is AC riding on DC?
Right,
Noise.
on the top of the DC. But that they call a ripple. And now what that means for ripple?
The noise.
The noise, the frequency underwater.
The noise.
The noise.
The noise means unwanted signal. If you're working with the government, when we design the circuitry, they have to asking you how many percent of the ripple have to be 0.1% or 0.01, depend. Okay, they don't want that signal. That's the noise.
Hey, Mr. Pham, can I ask you a question on that?
Yeah.
Can ripple or noise, is that the same as like a distortion?
Right.
Okay, thank you.
The thing I did, the capacitor, they will be charging, discharging. That's why. Now you can see in here, they given you a little more detail on the capacitor. Okay. So you get the sine wave coming in. Okay, so positive, the current flowing, they will be charging on the capacitor. Okay, they will be charging, keep going up. And then when they go to the negative here, the capacitor will be discharged. Okay, that's a very simple thing. And now you can see in here, you see that when they charging up, and when you get to go into the negative here, they start discharging. Okay, that's why you can see the ripple. See a little more. Okay, so this is a larger ripple, means less effective filtering. That means the filter not good. So that's why you can get a bigger ripple. However, it's a smaller ripple, mean more effective filtering. Generally, the larger the capacitor value, the smaller the ripple for the same input and the load. Bigger size of the capacitor will be discharged slower. That's very good for the guy to read, to memorize. Okay, now see what's going on here. For the transistor circuitry, okay, when they measure at the base, they get 0.7 volt. And they get at the collector 12 volt. And here they get 10 millivolt. The question is, what caused the problem? Which one priority to remove and replace.
R1?
You say remove R1.
RC.
I think so.
Problem with RC.
Don't you have to work out the formula for VB to make sure that's okay? In other words, you got 12 volts times R2 all over R1 plus R2 and make sure that's right?
It can be wrong a little. However, when you're looking into that, then you're able to identify which one you're supposed to remove first. The thing is, they can more part need to be removed. However, my question is the priority.
The transistor.
Perfect. The remove and replace R and R in this case will be transistor. Why? Okay, I can tell you, you get a 0.7 here. That's enough good to turn on the diode here, right? That means you still get any voltage here, even if wrong or right, doesn't matter. However, when you get a 12 volt in here, and you get a 12 volt in here,
There's a short open somewhere.
normally the resistor will be open, not short. So that only telling you one thing, the transistor not working. So that's why they open, right? They will be open here.
It's the diode from base to.
Whatever.
Okay.
Inside the transistor, we don't care. Okay? But they're telling me the remove and replace is supposed to be a transistor. The thing a transistor not working, right? So that's why when they measure 12 volt here, they measure 12 volt here. That means the current cannot flowing from here down here. Okay, that's the one thing. The other thing, when you try to remove or replace the part, remember, remove and replace any active component. R have to be followed. Number one, active component. Number two, then you can be capacitor, inductor. Number three, resistor. The thing is, capacitor can be more easier get a problem than resistor. Active component. How much you understand about active component?
Those need power.
Perfect. Any device need the power supply. Okay, then they will be active. Like the transistor, JFET, op-amp. Okay, that is
Any of the chips,
what?
like the ICs and stuff?
Right. They need the power.
Mm-hmm.
Okay, maybe that one. Last part here. Basically, you can see they want to see the signal within our input output. They will be in phase. they can be out of phase, or they can be leading, okay, or lagging. If you're looking on that one here, between input channel 1, input channel 2, what happened? They will be
180 degrees out of phase.
that will be 180 degrees out of phase. Correct. That means up opposite. They go up, this going down. Okay? That opposite. And if you see one go this way, the other one go this way, only bigger. What here?
In phase.
In phase, correct. Now, on the number 2, okay, number 2, they display input of channel 1 and input channel 2. So in this case, they not out of phase. They not in phase. Okay? They will be either signal channel 1 leading on channel 2 by how many degrees? Okay? If channel 1 leading channel 2, then they can say the same. Channel 2 will be lagging. That means behind channel 1. Either way. Then you need to do a calculation how many degrees. Okay? Either they leading or they lagging. Okay? So in order to do the calculation, I can give a very quickly. For the channel 1, you get a cycle, one cycle here. See that? This is a one cycle. And you calculate, try to see vertical, okay, how many versions, how many divisions? 1, 2, 3, 4, 5, 6, 7, 8, right? You see that? For vertical, 8 division. For complete one cycle. Can you follow that?
Yes, sir.
What equivalent in degree?
360.
360.
360 degrees. So now one division equivalent how many degrees? 360 divided by
8.
what you get?
About 45 or something. 50.
360 divided to 8.
345. 45.
360.
Yeah, 45.
45.
8. 45. 45 degrees for each division. So now, if you want to see the leading or lagging how many degrees, you can see the first one right here on the top, okay? And the second one, this is on the top. How many division different?
3.
3. That means you take 3 times 45. That's what you can see.
135.
Yeah, that's what you can see. They leading or lagging. 135. Okay, now for tomorrow, okay, the test will be 25 questions. During the test, no question at all. Whatever you think, you just try to get A or B or C or D.
Hey, Mr. Pham,
Yeah,
the waveform on top, did you say that was in phase, or what did you say about that one again?
in phase,
I'm sorry?
in phase.
In phase, yeah,
Both go up, both go down.
right. And the one on the bottom is out of phase.
Right.
Okay, yeah.
Okay, for the test, if you upload it tomorrow, you get 100%, depending on whatever you get. However, after tomorrow, I will be upload the test number 2 for you guys to do. Okay, that means the second time you do again. However, will be no timing. Takes for you to the time to do it. And even you get 100, you still get C only. Just make sure you pass.
So are you basically doing it the same way you did it the first time?
Exactly. That means after the tomorrow, on Wednesday, I upload the test for you guys, test number 2. Then you have to do again. If you get 100%, you cannot get A. You only get C. If you're not doing any test, anything, stay forever with me.
Okay, I'm staying forever, Mr. Pham.
What happened if still doing and not pass then?
You stay forever too.
You went to sleep.
Hey, Kumi,
Yeah.
you're gonna be here until when me and Mr. Pham's hair won't be gray anymore. It'll be white.
That'll be the last one.
Smith, Mr. Smith, I will be there with you forever.
Okay, so we're
Me, Mr. Smith, and Mr. Pham, all three together.
Yeah.
Mr. Pham, I have a question.
Yeah, go ahead.
I'm sorry if you already went over this. I apologize, but I do not get out of work until about 5:45, 6 o'clock sometimes, and you guys are already halfway through the test at that point. Is there any flexibility with my schedule, or is it automatic C?
Okay. I will let you to doing after tomorrow test and still get the full credit. Is it okay? The thing is, normally the test can be stuck around, let's see, 6:15. That take about 75 minutes. And this time I don't have any problem to let it run automatically. I already fixed the problem. Okay? If you get the problem, the thing is you cannot come on time. You be late, the thing is your work. That's okay. You guys will be separated to download and do it.
Okay, I appreciate the flexibility.
Yeah.
Hey,
Thank you.
Mr. Pham, one other thing too. All of these things, as it says in the beginning, they're all on the video. They're on the recording.
Yeah, everything will be on recording.
Okay.
Only thing what I want to help you guys to get a technician job. I don't care much about, you get the A or B or C or D. But you have to show me you want to be, okay? That means you have to do it. If it's wrong, then we try to help you out. You must be understand to get the technician job. Okay? So give me a lot of work. We'll be see you guys tomorrow.
Thanks a lot.
Can you
Mr.
help
Pham.
us write a resume? I'm kidding.
Hi, you is here, and I know you will be help you how to find a job. And will be given a very good, recommendation.
Thank you, sir.
Someone, company they asking me more later for student. So someone I answer, someone I'm not. Okay.
He's the first draft choice.
The thing is, you've been in a class with me a year. I already know who do it, who can do, who cannot do. Okay? So, good luck tomorrow.
Okay.
Thank you.
Thank you, sir.
Mr. Pham.
Thank you.